It's not just a little bit beyond Neptune or Pluto, it's like 50 times farther away. We want to call it Planet 9 and make it all part of the family, but this thing is so far away that it has yet to complete an orbit around the Sun since the Ice Age. The universe is filled with bizarre phenomena, but then Earth is all we know, so it's possible that what seems wild and exotic to us is likely common throughout the cosmos. However, that doesn't take away from the fact that space is filled with many oddities that astronomers are just beginning to discover and unravel. Here are 8 contenders for the most bizarre space phenomena in the universe. Number 1, Pulsar Planets. Scientists discovered the first exoplanet 30 years ago, but this one was orbiting a pulsar. Before you dismiss pulsars as an ordinary space oddity, you should know that they are born when a massive star, almost 25 times the mass of our Sun, explodes in a supernova event. These are extremely energetic events that blast most of the progenitor star apart. But just as most of the star gets flung out into space, the inner part of the star falls in on itself under the force of gravity. The event creates fascinating and equally terrifying outcomes. The first one is the compression of 1.4 times the Sun's mass into a diameter no bigger than a regional town, so you can imagine how its density would be off the charts. This region is so dense that a teaspoon of this material would weigh as much as all of humanity combined into a big ball of mush. The high mass and density of these compact remnant objects aren't their only notable characteristics. They also spin incredibly fast, even faster than a kitchen blender, and possess extremely strong magnetic fields, trillions of times stronger than a refrigerator magnet. These traits are inherited from the original star but become more pronounced as they are compressed into a smaller volume. The fast rotation and strong magnetic field of this rapidly rotating massive object provide the perfect conditions for generating radio emissions from its magnetic poles. As those beams sweep past our view, we see a pulse. It's like a cosmic lighthouse flashing in radio wavelengths, but these lighthouses can spin as fast as 700 rotations per second. In 1967, radio astronomers at Cambridge, including 24-year-old graduate student Jocelyn Bell, discovered highly regular radio signals while searching for quasars. They initially thought the signals were human-made or possibly from intelligent extraterrestrial life, but they were later identified as coming from a pulsar. This pulsar, originally nicknamed LGM-1, Little Green Man 1, is now known as PSRB 1919+21. According to the University of Cambridge, scientists have identified over 3,000 pulsars, and while these were all discovered in radio waves, we have since discovered these cosmic lighthouses in X-ray, gamma-ray, and even visible light. Can you imagine what life on one of these pulsar planets would be like? Since pulsars emit enormous amounts of radiation, life as we know it just couldn't exist. You would be living under a constant strobe effect of radiation, and the magnetic fields of pulsars would create the most extreme form of sandblasting the universe has ever seen. Number 2, the quiet black hole. There's a beast hiding at the center of the Milky Way, but the problem is that it's eerily quiet and barely moving. Sagittarius A*, a supermassive black hole with a mass 4.15 million times that of our Sun, was first detected in 1931 as a mysterious source of radio waves from the galaxy's center. However, it wasn't until 2002 that scientists confirmed these radio waves were emitted by something massive and compact, like a black hole, a discovery that earned them the 2020 Nobel Prize in Physics. But just before the team that discovered the black hole learned about their Nobel, another group discovered something new about it: it was moving slower than 10% of the speed of light. There are 3 characteristics all black holes in the galaxy exhibit: mass, spin, and charge. But this one did not have the spin scientists expected. Here's why spin matters: a black hole's event horizon grows as it gains more mass, reaching further and further from the singularity of the black hole. But as the black hole spins faster and faster, the event horizon shrinks. According to this theory, fast-spinning black holes should have smaller event horizons compared to slower-moving black holes of the same mass. Secondly, spin plays a major role in expelling white-hot jets of matter that sometimes launch into space at incredible speeds from a black hole's axis of rotation. Most Milky Way-sized galaxies have supermassive black holes at their center, and often these galaxies have enormous jets visible bursting from their cores, but not ours. Astronomers have not spotted any visible jets in the Milky Way. This fact alone indicates that the black hole at the center of our galaxy is not spinning very fast. It either has a small accretion disk, or it's barely spinning. It could also be both. But the bigger question is, why is the supermassive black hole so quiet? Now, that's a mystery we don't have an answer to. Number 3, Hoag's Object. In the October 1950 issue of the Astronomical Journal, astronomer Arthur Hoag disclosed the discovery of an object that appears to be a perfectly symmetrical planetary nebula. However, he admitted that some of its characteristics didn't match most planetary nebulae, making him wonder if he had stumbled upon a new species among the pathological galaxies. Today, we know exactly what Arthur Hoag found, a rare ring galaxy. This unique galaxy is about 600 million light-years away in the constellation Serpens and spans over 120,000 light-years. At the center, there's a sphere of older reddish stars looking very much like an elliptical galaxy. As you move outward, there's a seemingly empty gap until you arrive at the ring. The ring is made up of young blue stars highlighted by spokes that appear to curve, signs of rotation. This galaxy is so unexpected and incredible that astronomers are still trying to figure out how it evolved since its discovery. Ring galaxies can form when a smaller galaxy collides with a larger disk-shaped galaxy. This collision creates a density wave within the disk, forming a characteristic ring-like structure. But with this galaxy, astronomers are unable to trace any evidence of a past collision. Also, Hoag's object is spheroidal, while the nucleus of a barred spiral is typically disc-shaped. Believe it or not, that's not even the most remarkable feature of this galaxy. If you look closely at the Serpent constellation, you will see a galaxy within a galaxy. You can spot another ring galaxy in the dark gap between the two stellar circles. Isn't that amazing? Ever since Hoag's object was discovered, scientists have been looking for clues of its formation. If there had been a cosmic crash at the core of Hoag's object, it must have happened so long ago that all the evidence would have been swept away. With only a handful of known ring galaxies available to study, Hoag's object remains a mystery wrapped in a riddle inside an enigma, like a turducken. Number 4, Fairy Bubbles. Scientists made another astonishing discovery in 2010 using NASA's FY Gamma Space Telescope. Emanating from the center of our Milky Way galaxy, they found two bubbles made entirely of powerful gamma rays. It would have been peculiar if the bubbles, expanding at 2.2 million miles per hour, were concentric and centered on the galaxy's core. However, the two massive spheres are situated in what appears to be empty space above and below the black hole Sagittarius A** in the Milky Way's nucleus. These bubbles touch at the galactic center, forming a squat hourglass shape resembling the number 8 or a sideways infinity symbol. Their origins are still a mystery, but however they got there, they are emitting massive amounts of high-energy radiation. Most recently, the IceCube array in Antarctica reported 10 super-duper high-energy neutrino sources from the bubbles, which made astrophysicists wonder what crazy subatomic interactions were happening inside them. So how do you think these large balls of hot gas were formed? One thing we know for sure is that they would need energy, lots and lots of energy. But the kind of energy required to spread hot gas to a distance of over 25,000 light-years doesn't come easily to a typical galaxy. So where did this energy come from? Scientists believe the bubble's peculiar formation may be caused by the supermassive black hole silently positioned in the center of the Milky Way. It's possible that millions of years ago, Sagittarius A** ate a giant meal and got a bad case of indigestion. The infalling material heated up, twisting around in a unique dance of electric and magnetic forces, and managed to escape the clutches of the event horizon before falling in. That incredibly energized material sped away from the galaxy center on jets of particles nearly reaching the speed of light. As these particles moved outward, they dispersed and thinned but remained highly energetic. Or perhaps a star wandered too close to the black hole and was ripped to shreds, releasing intense gravitational energy in a single violent episode and forming the fairy bubbles. Another possibility is that Sagittarius A* has nothing to do with the bubbles. The culprit could be a multitude of stars in the core that went supernova simultaneously, ejecting the plumes of gas beyond the confines of the galactic core. Perhaps one of these theories is true, or perhaps none of them are. The truth is, we have no idea where the bubbles came from and what's going on inside them. Number 5, Fast Radio Bursts. If our NASA engineers know how to do one thing, it's how to send a message to outer space. For years, we've been transmitting a signal into deep space in different languages, hoping that someone or something will hear us and reply. While sending signals, scientists began noticing what they call fast radio bursts, FRBs. They range from repeating signals to single bespoke bursts of energy. Think of them as space's camera flash. They come from all over the sky and have frequencies ranging between 1,400 Hz to as low as 400 Hz. According to experts, there can be around 10,000 FRBs at random points in the sky every day, and while most bursts last less than 5 milliseconds, they produce more energy than our galaxy's sun does over weeks. Detecting FRBs is challenging due to their extremely brief and weak signals. Understanding their origin is equally puzzling. These FRBs originate from outside our galaxy, making scientists wonder if they are produced by magnet-Rs, rapidly rotating neutron stars with strong magnetic fields, merging white dwarfs, collapsing neutron stars, blitz-Rs, or colliding galaxies. They even considered whether the signals were coming from an extraterrestrial planet. However, the alien communication theory was quickly dismissed, and most scientists agreed that astronomical phenomena were the only culprits behind fast radio bursts. Number 6, Dwarf Planet Haumea. The infinite space is filled with infinite mysteries, and one of its leading contenders is the delightfully quirky dwarf planet Haumea. Although you might not have heard of little Haumea, she's definitely a big deal in the Kuiper Belt, where she's second in size only to Pluto. Haumea was discovered in 2004 by a team led by Mike Brown at the Palomar Observatory, though there was some controversy over the discovery credit, as a team from Spain also claimed to have discovered it around the same time. The planet is named after the Hawaiian goddess of childbirth and fertility, and its moons are named Hiaka and Namaka, after daughters of Haumea in Hawaiian mythology. Sounds like a harmless space object, doesn't it? That's where the dwarf planet has you fooled. While Haumea might look like the perfect skipping stone, if you toss this rock into the river would cease to exist. Haumea has an extremely fast rotation period, completing a spin on its axis approximately every 3.9 hours. This rapid rotation is believed to be the cause of its elongated shape, which resembles a weird oblong egg. She is the fastest spinning object of its size in our solar system, so a full day on this little planet would only last 4 Earth hours. But you wouldn't need to worry about adjusting your schedule because you'd surely freeze to death before even getting anywhere near its surface. The surface of Haumea is thought to be covered with crystalline water ice, giving it a high albedo, reflectivity. This icy surface suggests that Haumea has undergone resurfacing events, possibly due to its rapid rotation in past collisions. But the mystery doesn't end here. Haumea also has rings, like Saturn, but scientists are unable to draw a parallel between the two planets. How could this tiny, fast-spinning space egg have any rings at all? The source of these rings was probably an ancient collision, and astrophysicists look forward to one day solving this mystery. It's just one more bit of galaxy phenomena for scientists to decode in the future. Number 7, Planet 9. Planet X, also referred to as Planet 9, is a hypothetical planet in the outer solar system. Astronomers Konstantin Batygin and Mike Brown at the California Institute of Technology first proposed it in 2016 when they noticed wobbles in the orbits of Uranus and Neptune. They suggested its existence based on mathematical models and simulations to explain the unusual orbits of several trans-Neptunian objects, TNOs, in the Kuiper belt. These objects have orbits clustered in a way that indicates the gravitational influence of a large, unseen planet. Although the planet has not been observed directly, it is theorized to be about 10 times the mass of Earth and to have an elongated orbit that takes it far beyond Neptune, possibly taking 10,000 to 20,000 years to complete one orbit around the Sun. Despite extensive searches, Planet X has not yet been identified, and its existence remains hypothetical, prompting ongoing research and debate within the scientific community. Some astronomers believe there could be another explanation for the off-the-wall orbits of some of the more eccentric objects in the Kuiper belt. It's possible that a black hole is affecting the object's movement. It might even be a primordial black hole that was present at the Big Bang. Can you imagine the size of this theoretical abyss? If it even exists, it would be approximately the size of an average grapefruit. Scientists are hopeful they'd be able to confirm the black hole theory with the Vera C. Rubin Observatory in Chile. If they can capture proof of a flare in that region of space, they will be able to confirm their suspicions. While scientists admit that the probability is small, they seem thrilled by the prospect of having a real live black hole right in our galactic neighborhood. What are the odds of that happening? Number 8, Tabby's star. We've all grown up singing, "Twinkle, twinkle, little star," yet stars typically don't twinkle much. However, it was this twinkling behavior that drew scientists' attention to KIC 846-2852, also known as Tabby's star. This star dims in brightness by up to 22%, a phenomenon first noticed by citizen scientists using atom telescopes, which is an exciting aspect of its discovery. The leading hypothesis suggests that a ring of dust surrounds the star, causing the dimming effect as it moves. While this might seem like a boring explanation, many scientists argue that it's unlikely a dust cloud could cause such significant dimming. Another, definitely more exciting, explanation is that an advanced civilization is siphoning energy from the star using some kind of supermassive device. This theory takes a cue from the Dyson sphere, a hypothetical megastructure encompassing a star to capture a large percentage of its power output. According to experts, as a civilization grows larger and becomes more advanced, its energy demands skyrocket due to its population growth and the increasing requirements of its machinery. Hence, the Kardashev scale was developed to measure a civilization's technological prowess based on how much usable energy it has at its disposal. Kardashev originally proposed Type 1, Type 2, and Type 3 civilizations, but the scale has been extended since to include Type 4 and Type 5 civilizations. Interestingly, the human race is not even a Type 1 civilization. Building on the theory of advanced civilizations requiring more energy to survive, a Dyson sphere is a theoretical mega-engineering project that encircles a star with platforms orbiting in tight formation. It is considered the ultimate solution for a planet's living space and energy production. Perhaps Tabby's star is dimming because a Dyson sphere is sucking all its energy, or perhaps the Kardashev scale only exists in our minds, and there are no advanced civilizations out there. Another explanation for Tabby's star and its twinkling effect is the possibility of melting exomoons. An exomoon is a moon that orbits a planet outside our solar system. These moons are icy planetary bodies and could be spewing rocks into space as they evaporate or melt. If this is the case, Tabby's star could be slowly absorbing the exomoons. Although the idea of an alien construct sounds exciting, a star eating a moon is pretty cool too. With all the weird and wild objects in space, it's impossible to pinpoint exactly which ones are the most bizarre. Thanks to astronomers' tireless efforts, we'll surely learn of even more exotic cosmic objects in the future, ones that could potentially shake up our understanding of the universe forever. Hit the like button, subscribe to our channel, and press the notification bell for more videos.